Start, sir.
Yeah.
Good evening, everyone. A hearty welcome to all the teachers, students, Sri C.B. Singh sir from CSIR-NIScPR, Dr. Suman from CSIR-NIScPR, and especially Dr. K.V. George, Chief Scientist and Head APC, who has joined us here today. My name is Jolie Raji, and I will be your host for this webinar on behalf of United Schools Organization of India. I hope you all are ending this year on a high note, just as we are here at USO by bringing you the 9th edition of Science 101, Introduction to Atmosphere and Pollution Control. Just to give you a little briefing before we start. This webinar is being recorded and streamed live on USO YouTube channel. And your video and chat have been disabled. Chat shall be enabled during question and answer session, the end of the session. Now, let me tell you about the partners. United Schools Organization of India, USO, is a registered society established in 1951. It is our mandate to advance the social, cultural, and moral standard of schools in India to global levels by providing schools access to extracurricular tests, seminars, conferences, competitions, and campaigns on a national platform. Now, let me tell you the partner CSIR-NIScPR, the Council of Scientific and Industrial Research, abbreviated as CSIR, was established by the Government of India in September 1942 as an autonomous body that has emerged as the largest research and development organization in India. CSIR, National Institute of Science, Communication and Policy Research, New Delhi, came into existence on 1st April 2021 with the merger of erstwhile CSIR, National Institute of Science, Communication and Information Resources, New Delhi, and erstwhile CSIR, National Institute of Science, Technology and Development Studies, New Delhi. The new entity serves as a think tank for the Indian Standard 1 system and leads Standard 1 communication and policy studies at the national level, fulfilling the emerging national aspirations and needs. Now may I request Sri C.B. Singh, Senior Principal Scientist and Head of Jigyasa Department, Training and HR Division of CSIR-NIScPR. Sir, please say a few words of Jigyasa Division.
Thank you, Ms. Jolie. First of all, a warm welcome to Dr. K.V. George from CSIR-NIERI, who has spared time and who has postponed his traveling due to this particular session and interaction with the students. A warm welcome to students and the teachers pan-India who has joined this particular session. And particularly, as I had always been telling in my previous sessions also and the previous webinar series also, the main objective is that of this particular webinar is how to attract more students towards the science stream. There is an ample of opportunity towards the science if they take up the science stream. Then the ample of opportunities comes in the form of the speakers the students are interacting with. They had seen that a number of the scientists has been interacting with them. They have done a great job in their respective domain. So be it road research, then some health systems. Now we have come up with the say environment. So just to inculcate this particular webinar series has been organized, and this has been organized under the Jigyasa platform. The Jigyasa, it's a collaborative effort between the CSIR and the Kendriya Vidyalaya Sangathan. They have their schools which has been further extended to the state government schools and Sarvodaya Vidyalaya and Navodaya Vidyalaya schools also. There are the different ways to interact and to inculcate this the scientific temper among the students, which always like includes the scientist visit to the schools, then the children and the teachers visit to the different lab pan India of the CSIR, and different residential programs like the summer vacation programs, which takes place in the respective labs all over India. So these are the various means. Then, and step ahead, one more collaborative effort has been developed, which we call it as the Jigyasa 2.0, and which is with the IIT Bombay and MHRD. So they have come up with a digital platform or a portal wherein the different scientific activities in a very layman language that has been written, that has been animated, and has been uploaded onto the portal, so that the students can see and can understand the scientific, or they can satisfy their the scientific inquisitiveness. So all this comes up from that portal also. It is also an opportunity for the students, that the students can also, build up their own videos, small short videos, which has a scientific activity involved into it. And if it has been a committee sees that if it is good for the benefit of the other students, then it is also uploaded onto this portal. So this way we are reaching out to a number of these students just to bring that how science is beautiful for them. And they have the ample opportunities, job requirements. There is a lot of the job requirements also for the science stream students. So this particular topic in which the speaker is Dr. George, Introduction to Atmosphere and the Air Pollution, this is in very sync to the northern part of the India currently. Here we see that, yes, it's very cold out here. It's very smog, which includes the cold, the weather, along with the pollution. They mix together, and they come up with a smog, and then the visibility is down, creating a number of the hurdles in the movement and the other activities. So very much in sync. This air pollution, the introduction to atmosphere and the air pollution, students will really enjoy. So I'd like to again go back to Ms. Jolly to please give an introduction of Dr. George to the students and the teachers. Thank you. Ms. Jolly, your mic is mute. Please unmute it.
No voice.
Yeah.
Am I audible? Thank you, Singh sir.
Yeah.
Thank you. Sorry, I was muted. Now let us move to today's webinar topic, that is Introduction to Atmosphere and Air Pollution. That I must say it is very interesting topic. Okay, after the webinar, teachers and students can ask questions to our eminent speaker. We are delighted and privileged to have Dr. K.V. George for the 9th edition of Science 101 webinar. Dr. George is currently working as Chief Scientist and Head Air Pollution Control Division of National Environmental Engineering Research Institute, CSIR-NIScPR, Nagpur. He has worked in the field of environmental engineering for over 31 years. Dr. George has a bachelor's in civil engineering and mechanical engineering, environmental engineering from Government Engineering College, Jabalpur, and doctorate from IIT Delhi. During his career, he has worked for cleaning studies of Union Carbide India Limited, Bhopal, after the MIC gas accident. He also carried out environmental impact assessment studies for chemical industry, thermal power plant, cement plant, refinery and fertilization plant. Worked on source appointment study for industrial, urban and coal mine area, and was a member of Indian Antarctica expedition in 2000 for research work at Maitri Station. Currently, doing for major his activities our industrial area, Doha, Qatar, National Clean Air Program with Switzerland Development Corporation at different cities in India. Now, may I request Dr. K.V. George to take over the session. Sir, please.
Thank you, Jolly Madam, and thank you, Singh Saab. Am I audible? Can you give a comment?
Yes, you are audible.
Okay, so
Sir, you can present.
Yeah, so to take, should I press this button, take control?
Yes, of course.
Okay, so I'm uploading my slides.
Yeah.
Tell me if it is visible clearly.
It's coming, but it's not visible, sir. I think slides has not come up.
It's not yet come up.
Yeah, not yet.
I'm stopping sharing. And once again, I'm trying.
Yeah.
Open share tray. Allow Microsoft. Is it visible?
Yes. Yes, sir.
Is it in PowerPoint mode? Presentation mode?
Yes, we can see all. You can present, I think, slideshow.
Yes, it is in PowerPoint presentation mode.
PowerPoint presentation only. Yeah, PPT.
Yeah.
Okay,
F5.
okay.
And,
yeah, now I have pressed it already. So thanks. Now I'll address all the students. And my language of communication is Hindi, English. These are the two languages. So, and since I studied Hindi mostly in my school days, so I'll prefer, but I know you're all from Kendriya Vidyalaya, so you know good English also. So the title of presentation is Some Introduction to Atmosphere and Air Pollution. In this presentation, I will not be giving you answers or solutions. Rather, I will putting a lot of questions before you. You go study or browse through several websites and find the answers. That's how the subject can be studied well. If I give answer to everything, then there's nothing. First thing is that all students must know is what is CSIR-NIScPR. So CSIR stands for Council of Scientific and Industrial Research. I hope you can see at the top of this screen. And CSIR has some more than 28 laboratories. One of its laboratory is National Environmental Engineering Research Institute with headquarters at Nagpur. So this is the main entrance gate of NEERI. And yeah, it's visible now. Is it changing slides?
the slide is for me. The slide is still it's not being changing. The rest, please, Ms. Jolly, may please comment.
Yes, sir. I think it's sort of not a slide mode. Sir,
Okay.
can you present sir, now slide view, slideshow?
Okay, let me start once again the
सर पावर पॉइंट में जो लास्ट में एक वो है स्लाइड शो करके तो वो उसमें सेलेक्ट कर लीजिए आप तब पूरा स्लाइड वी कैन विजिबल नो
let me check whether it is moving up and down or not. This is actually about NEERI, so there are few lines with the blue text in between. Is it visible?
No, right now your system folders is visible.
Folder
your
sir coming.
It means there is something not correct at my end.
Sir, you just open PPT and there
Yeah.
is an option slideshow.
Yeah, there is an option, yes. So it's already there.
Animation.
Sir, there is a tab. ऊपर एक tab है. Animation
one?
slide, PowerPoint slideshow.
No, that's all. It's all there. But what I am looking is why it is not shifting or. See, what I am seeing is allow Teams Microsoft.com to see your screen. Okay,
Yes,
so I am putting.
but Microsoft screen we can see your
Is monitor. Now something is visible.
It's coming. I think.
Now it is.
Wait for a moment. I think it's not at.
Is it there about NEERI? And then
actually, we could not see right now. Right now, we could not see the slide.
Yeah, we can't see.
Miss Jolly, do you have that slide? The backup slide, do you have that?
Backup slides, sir. Could you please share with me so that I can just.
Okay,
We
I'll
can
do that.
share.
So that Dr. George can then direct that next slide. So someone at USO can shift the slide, or they can manually do it.
Is it seeing something?
Yeah, it is visible.
Yeah.
So should I continue like this?
Yes,
Okay.
sir. I think.
Yes, sir. You can continue with this.
Continue.
Yes. Yeah. Slides are moving.
Is
Yes. Please continue like this.
Is it moving to the text?
Yes. About NEERI, we are able to see the about NEERI.
And this next slide, CSIR to CSIR-NIScPR?
Yes,
Second
I think.
is about NEERI we have seen. If you can shift to next slide, please. Let me see whether it's moving or not.
This one?
Yes.
Yes.
Yes, sir.
Yes.
But this is not going in the slideshow mode.
Yes. It's.
So, students, apologize for this technical glitch. So, as I mentioned, CSIR is Council of Scientific and Industrial Research. This is under Ministry of Science and Technology. It has got some 29 laboratories. There are laboratories related to biological science, chemical science, engineering science, information science, physical science. Among engineering science, there are 10 labs. One of the labs' name is National Environmental Engineering Research Institute. It was established in 1958, and at that time the name was Central Public Health Engineering Research Institute, CSIR-NIScPR, Nagpur. And in 1974, our late Prime Minister Srimati Indira Gandhi renamed it as National Environmental Engineering. Now, you need to know a little bit about the difference of the two names. So, when we call public health engineering, is this slide visible, sir? Can you comment?
Sir, George, sir. I think the slide is not coming properly in YouTube channel. Could you please जो सर उसमें जो नीचे जो आपका PowerPoint स्लाइड में लास्ट में एक येलो लाइन बार है ना सर, ऑरेंज बार, उसमें माइनस के बगल में एक वो है स्लाइड शो का, उसमें एक बार क्लिक कर दिया तो पूरा दिखेगा.
This one? This one?
Yes.
But if I am shifting, is it visible now?
But it's all no.
No.
Click कर लीजिए सर, डबल क्लिक आई थिंक. 1 second.
Is it visible? What is in your home?
No, sir. This all slides are coming together.
No, it means it's
sir,
still not
orange bar है ना सर? Orange bar, नीचे जो orange bar है PPT का.
Yes, slideshow mode I have put it, but still it is not going.
Not going?
No, I have put all those things. So let me find some other way. I'll do one thing. I'll send this, but this is a huge slide. Will it go by email?
Yeah. Otherwise,
I'll try to send the PDF version. Let me see.
sir, you are enabled ना edit slide. तो वो I think enabled है. इसीलिए format background दिख रहे हैं सर. Format background.
हाँ.
वो disable कर लीजिए आप. Close कर लीजिए वो.
But nothing is visible for me.
This slide is coming for Microsoft Teams. Yeah. Come.
Is it visible?
Now go to slideshow. Yes, visible. Now go to slideshow.
Yeah. Now, is it changing? Because I am changing the slides. Seems it is not going.
Changing not moving.
Okay.
This
Madam,
is first slide. Yeah,
no.
moving, sir. Oh, then.
No. I'll send you the PDF. Please upload it.
You please share PPT with us so that we can share from our side.
Yeah, I'll do that. It has never happened with me earlier. Which email ID? Madam, which email ID I should send it now so that you get it?
Yeah, jolie.reggie@usoindia.org.
Okay. One PDF I have sent. This is followed by second one. Please check if you have received it.
Yeah, let me check it, sir. One moment. Yes, sir, got it. Let me download it.
Yeah, I have sent two.
Sir, this is
I have sent two.
yeah,
One is
PDF format.
No, I have sent one PDF and another this one.
PPT is not there, sir?
No, I have sent it second mail.
Okay.
Sent two mails. Yeah.
Okay.
Till then, let me try this also. Hello. Yeah. Mm-hmm. Mm-hmm. अच्छा, okay, okay. मैडम मैं अभी एक VC में
Yes,
हूँ.
sir, I received only
केंद्रीय
PDF
विद्यालय
format.
से.
Can I present
मैं
it?
आपसे बात करूँ?
Shall I?
Yeah, yeah. Sure.
PDF only I received.
Yeah, yeah. Hello.
Sir, I am going to share.
Yeah, please.
I think PPT also received. Let me check.
If you open PPT, that will be better because
Yeah. Let
a
me.
few animations are there.
PPT I will try. I received.
But madam, this is for the first time that I am finding this kind of trouble in Microsoft.
That's why I before lunch asked you because sometimes it happens, sir. No worries.
No, students are feeling.
I don't know. Yeah. Is it visible now?
Yeah, clear.
Presentation.
Yes.
Yes, in presentation mode. Go to next,
Yeah.
please.
Now, sir, can you please tell me which slide you?
It's
had
the
to-
first one. You please go to next. I'll tell you
Next
next.
slide. Okay. Is it okay?
Yeah. Yes. Next. 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 Next, please. No, previous slide it didn't go well. Is it in? No, previous one. Can I take control from here?
Yes. You can. I think you can take the control.
Now, this slide is visible, but only part is visible. The rest is not visible. Ah, okay. Is it visible now?
Yes, visible.
Okay. So I was telling the difference between public health engineering and environmental engineering. Public health engineering deals with water supply, treatment of water, wastewater disposal, solid waste management, sanitation, and health. Whereas environmental engineering deals with all public health engineering related issues, plus industrial waste, hazardous waste, air pollution, biotechnology, land management, etc. Now, what do you see in your home? So you have all these features in your home. You get this kind of wastewater. So one wastewater stream is from toilet. There is bathroom, sink, shower, washing machine. There is kitchen exhaust, vegetable, glass, plastic, etc. So these you can divide it into the basis of its phases. In this range, you can see bathroom, sink, shower, washing machine wastewater, which is called grey water. This you can use after some preliminary treatment in your gardens. Rest all is managed separately. Kitchen exhaust always goes out. Okay. Now, after seeing what is in your home, this is what is your city. So you have marketplace, residential area, industry, hospital, school, all have different kinds of waste generated. So pollution source is here. Then comes, if you go into a larger context, the larger geographical area, if you have a city somewhere here, you will draw clean water from river, use it, dispose the wastewater in the river. So how much water you can draw and how much you need to treat, you should plan when a city is growing. So this is something you need to understand. If the city is growing, it requires energy, large amount of power emissions are made from thermal power plants, large number of vehicles, emissions. So to what extent you can allow a city to grow in an urban setup? For example, Delhi, you know, it's getting polluted and it's worse during winter season. So therefore, you should control the city's size, and that's what is called carrying capacity. Then comes, now if you want to go to air pollution, we need to understand what is clean air. So let's go by the philosophical way. In Indian mythology, what we call Agni, Jal, Prithvi, Vayu, Akash. Whereas the same thing in Greek is fire, water, earth, air. Here they do not mention space or Akash. We have mentioned it. Now we are studying is what is clean air, then how it got polluted. So the subject is air and pollution. So before going to air, we need to know how air has come on our earth. Okay. So on the left side, you can see this is the earth, crust, mantle, core, this fraction, solid, liquid, gas. All these classifications, all of you must have studied in your, I think up to 9th standard, these things are pretty clear. Then this is
Hello, sir, George sir. Hello. നമുക്കൊന്നും ചെയ്യണോ?
call drop हुआ था in between.
Sir.
There was a call drop.
Okay.
You need to upload it once again.
One second, sir.
So where we were? Yes. So the earth is, am I audible, clear? Madam, am I audible?
Yes, sir. Yes, sir. Please
okay.
continue.
So now earth is based on its phase is differentiated as lithosphere, hydrosphere, atmosphere, or they call 3 great spheres of earth. Now I'm giving you few terms. Lithosphere, the study is also called terrestrial ecosystem. Hydrosphere, aquatic ecosystem. The other way is again classified as physical environment and biological environment. So when you study a subject related to this, you need to put it where it is. That will be easy for you to understand. Then comes the question of how Earth is formed, atmosphere, why oxygen and argon is large in amount and low level of helium, why desert on Earth, why rainforest, etc. So before going to Earth, we need to know first was the universe. The origin of universe. There are two thoughts. One is someone made the universe. It's an intelligent design of God. And the other is universe made itself by random chance. So these are the two schools of thought which are countering each other. We will go by the universe made itself by random chance. That's through Big Bang theory. The question again, those who believe in God says, who started the bang? So again, they says, no, there was an existence. There is an existence of God. So this is the Big Bang theory. All of you must be knowing it. Now, whether it is correct or not, but in 1964, 2 Nobel Prizes were given to Arno Penzias and Robert Wilson, who discovered that when the universe, the making of universe was in the process, the glow left is seen now. Those radiations have come now into our atmosphere, and these are the two scientists who made this equipment, this device which measured those long wave radiations and said, yes, these microwaves are coming now because of the Big Bang. Then this is the sun, how it is getting cooled down. Once it cools down, what happens? The earth around the sun, the earth is revolving, and this earth you can see slowly getting cold, and all water vapor is getting condensed in the deep depressions, thereby forming oceans. So at that stage, earth was, the atmosphere was of hydrogen, helium, carbon dioxide, water vapor, and dust. Now, one question that for the interest of the students I am mentioning here, and with a hint or some answer, why sun is glowing, continuously emitting radiation. So here, because of the size of the sun, now I am talking about sun, because of the size of the sun, the gravitational force at the center of the sun is very high, and atoms are getting diffused. So 4 hydrogen atoms, when they get diffused, they form 1 helium atom. And now here you see, here I have given 1.00794 is the atomic weight of hydrogen. If you multiply it by 4, you will get the atom, you should get the 4 times the hydrogen atom. But helium is little lesser than this. So where is the rest of the energy? Where is the rest of the mass? The rest of the mass is converted to energy, and this is what Sir Albert Einstein mentioned when he said when mass, how mass gets converted to energy. Now E equals to mc square is related to this. So this helps us that at the core of the sun, continuously this fission and fusion is going on of hydrogen atom, leading to release of energy. Because of that energy, the sun is glowing. Imagine another question: if the Earth's size grows as that of sun, this will also glow like sun, and everything will burn out. Because of the gravity, the hydrogens will fuse in each other. So this is something worth knowing. Now that here you can see where we stand, it's Earth far away from sun, and see the size, it is very small. Okay, so you hear the differences are given, but very small size is that of Earth. What if Earth size is increased similar to sun? This is one of the questions. You can write it down or you can refer. Now, evolution of atmosphere. So envelope gases that surrounds the Earth. First atmosphere was hydrogen, helium. Now these gases lost into the Earth's history because of their low molecular weight, and they are not, Earth's gravity was not able to hold it. Then second atmosphere, which is produced by the volcanic gases, was not having oxygen. Oxygen was not found during that time, because at high temperature everything was getting oxidized. Now you can see this periodic table. If you want to refer to the gases in atmosphere, you can see on top left red color, this is hydrogen. Here nitrogen, oxygen, fluorine. So hydrogen lost. Then comes nitrogen and oxygen. These two are here. These are all inert gases. Very small amount it is there. Fluorine, chlorine, they get reacted. So what is today in atmosphere? Nitrogen and oxygen. Now the question comes, from where oxygen came? Because in the initial atmosphere there was no oxygen. Everything was oxides of other elements. So there are two ways. One is photochemical dissociation, other is photosynthesis. You just need to remember these two topics. Photochemical dissociation is because of the input of ultraviolet radiation directly up to the surface of the Earth. Because at that time there was no ozone layer, no atmosphere, the entire atmosphere was transparent to ultraviolet ray that broke up the water molecule and small amount of oxygen present here. So, and breaking up of water molecule led to formation of oxygen, followed by ozone. Gradually, ozone buildup took place. When the layer of ozone was formed at the outer atmosphere, it prohibited entry of ultraviolet rays, and at the lower atmosphere, now it is free from ultraviolet rays, and thereafter the life started. And when the life started, this is the beginning, as per scientific knowledge, the blue-green algae or diatoms or cyanobacteria, they started conversion of change from carbon dioxide to oxygen and organic compounds, so which is now called photosynthesis. So initially it was photochemical dissociation, followed by, after a long time, once ozone layer was set up, photosynthesis. Now from there onwards, gradually the oxygen level build-up started, and today we are here when we have high concentration of oxygen. Then comes the question what is the level of carbon dioxide, because we are more bothered about greenhouse, global warming, etc. So there are two subjects. One subject is climate change. In climate change, there are two phenomena. One is greenhouse gases, which has carbon dioxide, methane, N2O. Remember, this is N2O, not NO2. And then ozone depleting substances, freon, which disturbs the ozone layer. Another phenomenon is air pollution here. So we are not talking much on the climate change. Instead, air pollution is our of concern today to some extent. And where carbon is stored, it's in deep ocean, rock, fossil fuel, plant, surface of ocean, and atmosphere. Now we are bothered about the presence of CO2 in atmosphere. Now you can see comparatively here, atmosphere is having only 720 gigatons of carbon dioxide, whereas deep oceans have 38,000. So atmosphere is nothing, but still why it bothers, you can see whatever fossil fuel combustion releases in the form of CO2, 47% goes into the atmosphere, and that is why global warming and accumulation in the atmosphere is of concern. The remaining goes to land and ocean. Now, composition of dry air. So this is what is the composition. You can say nitrogen, oxygen, argon, etc., of different volume. To understand it easy, this is the composition from academic point of view. For exams, you can remember nitrogen 78, oxygen 21, and argon 1, which is percentage, and these are its molecular weight. So this much is enough for you to know at this stage. I'll come to a few more issues on this. Now this atmosphere is, Earth is having atmosphere similar, same as if you simulate, apple is having its skin thick. So this relation exists for atmosphere thickness and Earth's thickness. And this was suggested by United States Environment Protection Agency. This is the extent of atmosphere. Now, how life started? So again, the dispute between the two. Someone made universe so intelligent design of God, whereas Darwin's theory explains something else. He says origin of complex life form from simple ancestors. Again, they put a question, counter question: who created this simple ancestor? Is it God? So now a little bit about Darwin. Sir Charles Darwin. All of you must have heard of film Tom, Dick, and Harry, a film in which Ritesh Deshmukh acted. But remember, these three words, these are the names of the tortoise collected by Sir Charles Darwin from Galapagos Island. And one of these tortoise was gifted to Steve Irwin's Australia Zoo, and this was born in 1830. As I understand, recently it died a few years ago at the age of something like 180 years. Now, Darwin's theory, it speaks something like this: from gibbon to orangutan to human being, whereas this is the Darwin's theory. So what believers says, those who believe in God, that when there was change from animal to human being, this was the stage, and finally a man is like this. This is actually a caricature of Sir Charles Darwin. Now, this is how we reached our planet Earth. I'm moving fast because we have lost a lot of time. So I'm just giving you some questions or points to think, that's all. Not a detailed explanation. Now, how life is maintained on Earth, you need to pick this word, this slide very clearly. There is hydrologic cycle. This brings fresh water. If everywhere water is just kept stagnant, we'll get stale water after some time. So fresh water is because of hydrologic cycle. Fresh air is because of wind. Then wet and dry season and high low temperature. This brings food. Because if this cycle doesn't exist, the life form will destroy on Earth. Okay. Now, I'll explain only one cycle. That is hydrologic cycle. All of you must have studied, but still a quick view. This is water body, land mass. Sun is heating both. Land mass is getting heated at a higher rate, so it is getting heated early. Whereas water body, the latent heat or Gupta Ushma, the moisture moves up. Now, because of the heating of land mass, vertical convection starts. This pushes this water vapor into the higher level. At higher level, it encounters low pressure in the atmosphere. Because of low pressure, it expands. Adiabatic expansion causes lowering of temperature followed by condensation. So all of you have studied this subject. Then rain takes place. So this is how water from ocean, it comes to the land and comes back because of the slope. So this is the hydrologic cycle. Another cycle you can see, current rather, wind and water current. So sun rays are directly on the equator. This is the equatorial line. So water here is warm, whereas on the polar side, the water is cool. Because of the difference in temperature, the ocean current takes place. Okay, when ocean current takes place, it drives nutrients from different parts of the earth, from equator towards pole, and that causes, because of the spread of nutrient, the marine life survives. Again, another issue is unequal solar insolation on Earth's surface. The Earth is tilted by 23.5 degrees, so polar area gets lesser radiation and equator gets higher radiation. Because of this, the differential temperature heating takes place. Then, I think one figure is missing. Can anyone suggest, is it visible, the desert and land?
Yes, sir. Visible.
Yes.
But I'm not able to see. Anyway.
So, sir, this is unique heat retention by Earth's surface.
Yeah, so you are able to see the desert area.
Yes, yes, sir. Vegetative land vs desert.
Not on my screen. Okay. So what is happening here is there are deserts which receives heat and gets heated up at a different rate compared to vegetative land, which may also receive the same amount of radiation but heats up at a lesser rate. These two rates are different. That's what is something driving. Difference in heat drives the atmosphere circulations or cycles. Another issue is elliptical orbit of Earth's rotation. So here you can see Earth is rotating in elliptical shape, not in circle. Our normal human tendency is to think of a circle, but here it moves in an ellipse. Now you can see how many non-uniformity or asymmetry is there. So Earth is not a perfect sphere. Earth's axis is tilted by 23.5 degrees. Earth does not rotate in circle. Instead, it is elliptical. 60% of southern hemisphere is water and 40% is land, and vice versa. And land is covered by vegetation and desert. Now you can see there are so many asymmetries. This asymmetry is causing life on Earth. Now, if you want to simulate this in society, a society which is having different type of people, and India is one of the best example. You have so many languages, cultures, and that's why we are the best. Okay. Now let me come to the point. How another point is how air got polluted. So I'll touch each points quickly. We realized the importance of heat long ago. We came to know about the knowledge of fire some 15,000 years ago. Then came Stone Age, Bronze Age, Iron Age. Now, till then, we were able to create or rather generate metals by its reduction, its reaction with carbon or carbon monoxide. This is something where we can say that yes, metal extraction started. For metal extraction, we needed carbon. We used wood or charcoal as a source of carbon. Then sea coal at England was the first carbon coal mining. Then what are the rules? So in 1306, in London, there was a royal proclamation, and those days the proclamation was अगर किसी ने काला धुआं निकाला तो गर्दन काट दी जाएगी. They were very, very tough those days because there was an era of kings, not unlike our law of rules, संविधान जैसा नहीं था. Then gradually people realized the importance of ill effects of this carbon emission and all those things. Then came industrial revolution. So all those who are interested in higher studies and competitive exam, they should understand, realize and remember these things. Industrial revolution, 1760, 1760, 1830. These are the things that came into existence. Scientific inventions, hand production methods of to machines production, machine tools, chemical manufacturing, iron production, improved efficiency of water power, increasing use of steam power. Very important discovery was James Watt's invention of steam engine in 1765. So gradually we are shifting to first industrial revolution, then second industrial revolution, where locomotive was invented by George Stephenson, Michael Faraday's electromagnetism, and that's how gradually we are shifting. One of the most important invention was Nikola Tesla's invention of alternating current. Now, why it is important? Because alternating current can be transported. So in 1887, he discovered that alternating current can be transported, and therefore electric power transmission started. This is something very useful. Even today, if someone can generate create a device that transports direct current, then that will change the game all over the world. Now, for this purpose, since electric power was, they were able to transmit large amount of coal was extracted for thermal power station. So the importance of coal and power plants came into existence. And from here onwards, the pollution started. Okay. Now I'm shifting. Now, from when the power plant led to more emissions. Now see what happened. June 5, 1972, Rio de Janeiro, Brazil. Many countries gathered to discuss air pollution, an international problem between United Kingdom and Scandinavian countries. Now, what is Scandinavian country? Let me show here. If it is clear, this is United Kingdom. These are the Scandinavian countries. So what was their complaint? From here, when you use thermal power plants for power generation, the emission is going in this direction and they are damaging the forest and lakes. Fish kill is taking place. So let me go to previous slide. So Scandinavian countries, Denmark, Norway, Sweden, Finland, they were losing green forest due to particulate matter, sulfur dioxide from UK power plant. So they went to international court. Now this is the point where you need to be a little cautious. Definition of air pollution is coming. As a fallout of their going to international court, the United Nations Environment Program came up. And they gave a definition of air pollution as transfer of harmful natural synthetic material into the atmosphere as direct indirect consequence of human activity. So this was the definition, and remember this day, June 5. So this is what we celebrate as Environment Day because of this air pollution issue. Means when they met at Rio de Janeiro, Brazil. Now these are on the, you can see the emission from power plant. It shoots up very high when the exit velocity is very high. So this is how they were able to travel to other countries, creating a transboundary problem. So this was the Scandinavian countries issue. Now I have a question for you. This you need to understand some tricky questions. Wet or dry handkerchief is heavy. So obvious answer is wet handkerchief is heavy because it absorbs moisture. Another question is dry air or wet air is heavy. Which one is heavy? So we think on this line, but here let us study something like this. Let us first understand what is the molecular weight of air. So air is having two components of nitrogen, oxygen. It is having its volume is fractionally 0.78 and 0.21 or 78 and 21%. Fractional mass is multiply both. You will get these two. If we add, we will get the molecular weight of air. So you need to remember this term. Molecular weight of air is 28.56. Because we have chosen only two, if you take or argon also, it will become 28.96. Now, from here you can say the molecular weight of air is 28.56, whereas molecular weight of water, H2O, is only 18. 16 plus 2, 18. Since moisture is having lesser molecular weight, if we feed moisture in air parcel, making it a wet air, its weight will come down because the amount of volume that is going to be occupied by moisture or water vapor, that much of dry air will have to be pushed out of that system or that control volume. So what we are doing is we are replacing something worth 28.56 gram with something which is 18 gram, and therefore remember dry air is heavier than wet air. Now we have come to know of nitrogen and oxygen recently, some 1772, 73, 74, whereas Sir Isaac Newton stated this in 1770. So now imagine how Sir Isaac Newton was able to decipher that dry air is heavier. Some of the examples which we see today is announcements are clear early morning. Why? Because early morning the moisture gets precipitated because of low temperature. You can see dew formation, or your car or vehicle is having some dew on its surface. So the atmosphere is dry. If it is dry, density is high and sound travels fast, and therefore by 4:30, 5:30, between this period you can get clear announcement from distant railway station or bus stop. Then golf ball goes larger distance during dry weather or wet weather. During dry weather, it offers larger resistance, whereas during wet weather, the resistance is less. So golf ball goes to larger distance during wet weather, not during dry weather. So from their experience, it was deciphered that yes, the wet atmosphere or air is lighter than dry atmosphere. If we take three gases, the molecular weight is 28.96. So approximately 28.5 is sufficient for your calculations. Then the question comes, how rain takes place? This you have studied. I am giving you a very small example. The perfume in a bottle, this itself is not cold, but when you press the button and release, you get your skin gets cold. Why? Because when you press this button and release liquid perfume outside, the pressure inside the bottle is high, outside pressure is low, molecules goes farther away. And when the molecule goes farther away, it means some work is done. For doing that work, it extracts heat from the surroundings, so this area becomes cold. So what it does, if you are hitting it on your skin, it will extract heat from your skin, and that's why we feel cold. So similarly, when the cloud moves higher into the atmosphere, where the pressure is low, it expands, and when it expands, it draws heat from the surroundings, and temperature comes down. And temperature comes down, because of low temperature, the moisture holding capacity of atmosphere lowers down and the precipitation takes place. You can read it. I'm just trying to give you through this graphic example. Here is the saturated parcel where relative humidity is 100 and temperature is T1. Suppose you reduce the increase T2, increase the temperature of this parcel, it will get more ability to hold moisture. So you can feed in more moisture. Whereas at the same time, if you reduce its temperature, then if it crosses its saturation limit, the moisture will come down. So this is what happens in the atmosphere. The question comes, why temperature changes in the atmosphere? Because the air parcel goes to a higher elevation where pressure is low, it expands and the temperature comes down. Now, another point, why there are deserts on Earth? So I am trying to give it through an example. Actually, this is something where I wanted you to see an animation, but I doubt it will be there. So suppose this is a canal on which water is flowing. If the water is flowing, if you draw a curve of water velocity, top surface velocity from this edge to this edge, it will be something like this, a parabolic shape. Now, if you put a tube of a truck tire, what will happen? In which direction it will go? It will not only go towards the forward direction, it will spin. Why it will spin? Because on one side of the tube, velocity is high, and on this side, velocity is less. It forms a couple and it will start spinning. So this has got two motions. One is spinning and another is forward motion. Same thing happens in atmosphere. Okay. Now here let us see. Suppose this is the Earth, and this is the equatorial line. This is the line of Cancer. So when the Earth spins, its velocity is at the equator is 1750 km per hour. At the poles, let us assume it is 0. Okay. Line of Cancer, it will be 850 km per hour. So there is a couple formation. So air lying between these two lines, line of Cancer, this line of Cancer and equatorial line, this will have a couple like this. Here it will offer higher velocity, here it is less. So what happens? It will spin, you can see. And it will spin in this direction because here the velocity is high. On the contrary, if you take its mirror image on the southern hemisphere, it will move in reverse direction. So here it is anti-clockwise, here it will be clockwise, because here line of Capricorn, again higher, lower velocity the air parcel will encounter. So this diagram you need to understand clearly. If you want to understand how desert forms. Now from here you see, when solar insolation is high on the surface along the equator, this causes large amount of moisture to move up. And now this large amount of moisture, when it comes at a higher elevation, it expands, causes rain, and that is why the Brazil, South American continent, that patch gets very high amount of rainfall. But what happens here, the moisture, after releasing the moisture, dry air has moved in this direction. Now dry air is heavier, so it settles down. Once it settles down, let us see some other figure. Yeah, this is better one. From equator, air parcel moves up, it expands, causes rain, and then when it expands, the dry air, after releasing the air, moisture, dry air comes here. It settles down because of its higher weight, because it is dry. It comes here. Now, dry air is having a tendency of absorbing moisture. It will absorb moisture from here and goes in this direction. So this circle is maintained. Okay. So what is happening here? Precisely this dry air is falling down and drawing the moisture from here. Same thing, and so this is called Hadley cell. Farrell cell and Polar cells are different. Today we are just discussing only on Hadley cell. So this diagram you can see from here. This is the equator. The dry air, wet air moves up, causes rain after expansion, and dry air falls here and takes the moisture from here and again comes back to the equator. So this motion is causing formation of desert. You can understand Australian continent, the desert is on this side. Why there is no desert on this side? Because the makeup water is coming from from ocean. Here again the makeup water is coming from ocean. Here again you can see in all the continents on the western side the deserts are there, not on the eastern side. This is something for you to understand. Then I think it should be the last topic. Why radio signals are clear at night and not at daytime. Those who are fond of listening to Vivid Bharati and Bhule Visre Geet, they know at night radio signals are clear, they can listen to music. The reason in the atmosphere, let's come. This is the atmosphere. From here, from 20 to 50 kilometer patch, you can see ozone layer. So this is divided as troposphere, stratosphere, mesosphere, thermosphere, and then ionosphere. There are several ways. I'm leaving all these things. So in this process, let me come. Yeah. Here what happens? The radio signals are reflected from this ionospheric layer. And this layer is actually, there are three layers, D, E, F in ionosphere. This layer reflects the radio signals to your radio. So this transfer is clear at night, whereas during daytime, because of the width, this width increases. So there are several layers which is this reflecting this radio signal. Because of multiple reflections, we get multiple signals. That's why we get that noise. Whereas at night, there is no sun. In the absence of sun, this layer is thin. Why thin? Because it is ionosphere. Ion formation is low during night time. So I think this should be the last slide. These are all the different type of different layers. What is K-line, aeronautics, astronautics? I leave it to you to study. I think this should be sufficient. I have picked up all these images from different sources, and this is only for educational purpose to school students without any profit-making objective. So please don't look for any copyright issues. Thank you. Children, if you have any question, or please come forward. Over to you, madam.
Sir, it was a very wonderful, informative session. Thank you, sir. Now I request teachers and students, do you have any questions? Please, I have opened the mic and as well the chat box also. You can type in the chat box.
Madam, how many students are there? Some 10 to 15. I'm not able to see here.
I am also not available. I can't see because I am in Teams right now, sir.
I think
I will share all the tomorrow, and by day after tomorrow I will share all the details. We will share the report, sir. Attendees and everything. We will share with you. You will get a report, sir.
12 students are there, I think.
Yeah. So teachers have already joined. I think around 70 teachers. May I request any questions? Do you have, teachers?
Either the topic is too self-explanatory or nothing entered in here. Either of the two possibilities. It's mentioned 5 minutes left in your meeting, I think.
Yeah, it's no worries, sir. I think it.
So please tell. I think there is no question. There is no chat box visible. So students are accessing it from...
Students can't access this chat box because we are provide the YouTube link only. The teacher teachers can type it here because the students will ask to the teacher and the teacher will normally usually doing like that.
Okay. I think today we have spent full 1 hour
yeah,
because of the delay. Otherwise, we could have gone much faster.
Yeah, it happens sometimes. It's a network issue, maybe. I think it was very, very wonderful. This is an interesting topic. It was very interesting topic. We think how to control the pollution, by air. That's even in Delhi. It was last month. It was too high. High pollution was there.
To understand that point, why the Delhi only during this winter period the pollution starts and not in summer. So we need to understand the cleaning mechanism, atmospheric cleaning mechanism, which is related to mixing height and ventilation coefficient. So during these 2 months, the ventilation is less, mixing height is less, and wind speed is less. Whereas in the month of June, it is very high. So there is a clear-cut explanation, and I have another set of presentation.
I think from our side, because he is doing internship at we know he has written how many states and especially in northern India, facing pollution crisis. So my question is, how can we as a developing country can reduce the existing levels of pollution and improve the air quality?
Okay, so I think this is a question from intern USO.
Yeah, intern. He's doing intern.
Okay, let me answer to this question at least.
Yes.
Thanks. There is one question. I
think Miss Nina also joined.
Has joined. Yes, he is here. Let me answer this question. First of all, you should question yourself why you are raising this question only for winter and not for summer. So let's analyze the air quality data of summer and winter. So, and there is no change in activity. Earlier, a month ago, there was an issue of stubble burning from Punjab, Haryana. Now, all those things are over. So, when everything is over, why we are saying that Delhi is still polluted, NCR is polluted? It means something else is happening. Diwali is over, stubble burning is over. Still, January, December, these 2 months will remain polluted. Though all emission activities are same throughout the year. If we remove all those critical festival and stubble activity, agricultural activity, it means something else is happening in the atmosphere. And what is happening is, actually atmosphere is not ventilating the pollutant, it has accumulated. So in the entire NCR region, if you find a mixing height, what is mixing height? Mixing height is a term used for the height above the Earth's surface up to which our pollutant gets mixed. So if this height is small, it is same as our room. Where we are sitting, if the height of the room is small, then we will get exhausted early. But if the room of height is large, for example, theaters, you can see large number of people are sitting, and that's why the height is very high. So that can, whatever we are exhaling, that can be vented out, or that can be stored in a large volume. So our atmosphere is also having a mixing height, which is a function of temperature profile from surface to the upper direction. So during winter months, this mixing height is very low. It's hardly 10 to 20% of the mixing height of June mixing height when it is highest. Summer is at its peak, Earth is getting heated, vertical convection takes place, and mixing height is maximum. Wind speed is also very high during May and June compared to November, December, January. So what happens? The ventilation of an atmosphere is calculated by multiplying mixing height with wind speed. So at this moment, your wind speed may be 2 or 3 meters per second maximum. whereas during summer, your wind speed is relatively high. So you multiply the mixing height and wind speed, which is called ventilation in terms of meter square per second, you will find it is barely 15 to 20% of the June mixing height. So whatever emission is there, it remains in the atmosphere of not only Delhi, it's the entire Indo-Gangetic plain. It doesn't move ahead. For this to move ahead, what is required is the solar insolation should heat up the ground. Once it heats up the ground, vertical convection and the temperature structure of atmosphere changes. That causes the mixing or the release of pollutant from the city's vertical atmosphere. So I hope I have explained you something worth you understanding why Delhi is polluted now. You will not raise this question in May, June, July. Okay. Any other question? There's no question. Chat box is not too accessible to me. Or it's there, meeting chat. Yeah, there is nothing.
Any more questions? Thank you, sir. You explained in detail. It was an informative session. If you have any, I think no more questions from the teachers.
Yes.
Now, let me tell you, the next webinar will be scheduled for next month, in next year, last Friday, January 27, at same time at 4:30. Details shall be shared later with you. And thank you so much. Thank you, George sir. You spent your valuable